They say hackers break in through the front door, but the true elite, they don't knock. They dismantle the entire house. Reverse engineers aren't guessing passwords or scanning ports. They're taking your software apart piece by piece, reading its soul and revealing the secrets that were never meant to be found. No source code, no access, doesn't matter. They'll pull apart the binary, disassemble the logic, and reconstruct the hidden architecture behind every instruction. This isn't surface-level hacking. This is digital archaeology, system surgery, code-level espionage. If hacking is an art, reverse engineering is the blueprint behind the masterpiece. And in this world, there's no such thing as secure, only hidden. Scene 1. What is reverse engineering? Reverse engineering is the process of deconstructing a finished product, usually software or hardware, to understand how it works internally. It's like working backwards from the final result to uncover every step that created it. Think of it like reading a book, written in another language, encrypted, without a title. Instead of having the original source code, you get a binary, just raw compiled instructions. And yet, through patience, experience, and analysis, reverse engineers decode it. They uncover logic, control flow, data structures, hidden backdoors, and even developer fingerprints. It's not just about hacking into things. It's about understanding them at the deepest level. If penetration testers find holes, reverse engineers map the entire skeleton. Scene 2. The toolbox of a digital surgeon. To reverse engineers, IDEs like Visual Studio or Xcode are child's play. Their tools are raw, precise, and built for brain surgery on code. At the top is IDA Pro, a legendary disassembler and debugger capable of turning binaries into navigable graphs. Then there's Ghidra, the NSA's open-source powerhouse, allowing for deep analysis and decompilation. Binary Ninja, Raider 2, and OllyDBG follow, each offering unique abilities to dissect, debug, and manipulate code in real time. Hex editors let them inspect raw bytes. Dynamic analysis tools allow memory breakpoints and syscall tracing. They don't just look at software, they live inside it. For them, functions are puzzles, strings are breadcrumbs, and memory maps are treasure maps. Scene 3. Real uses that feel like superpowers. Reverse engineering gives hackers real-world superpowers. In the world of software piracy, it's used to crack commercial programs, removing license checks, disabling trial timers, and unlocking premium features. In gaming, it opens up the inner workings of titles, revealing hidden debug modes, cheat values, or even unactivated content. But it's not just for fun. It's vital in malware analysis. Cybersecurity experts dissect malware using reverse engineering to understand what it does, how it spreads, and who built it. It's how we uncover ransomware logic, identify nation-state attacks, and respond to zero-day threats. In mobile hacking, reverse engineers tear down APK and iOS apps, bypass security features, and extract secret keys. Even embedded systems, routers, smart TVs, medical devices can be ripped open and studied. When something breaks or threatens to, reverse engineers step in. Not to guess, but to know. Scene 4. The reverse engineer's mindset. The reverse engineer doesn't rely on luck. They rely on obsession. When most people see a black box, they move on. The reverse engineer sees a challenge. They stare at assembly code, trace logic through dozens of function calls, and read memory dumps line by line until the story reveals itself. They build mental models of machines, tracking variables, registers, memory addresses. They operate in spaces where no documentation exists. And when they get stuck, they don't quit. They dig deeper. It's not about speed. It's about patience, clarity, and the ability to see patterns in chaos. They don't break systems. They reconstruct them. Scene 5. The ethics and legal gray zone. Reverse engineering exists in a murky legal space. In cybersecurity, it's completely legal and essential. Companies rely on reverse engineers to analyze malware, hunt vulnerabilities, and secure systems. But when it comes to reverse engineering commercial software, cracking DRM, or tampering with intellectual property, the law gets tricky. In some countries, reverse engineering is protected for compatibility and research. In others, it's illegal if it violates end-user license agreements. The same skill set that uncovers ransomware logic can also bypass a subscription lock. That's why intent matters. Ethics matter. Because the line between a white hat researcher and a black hat hacker isn't the tool they use. It's what they do with it. Scene 6. Breaking the unbreakable. The most powerful software today is protected by multiple layers of anti-reverse engineering techniques. Obfuscation, encrypted code segments, anti-debugging traps, virtualized execution, and code polymorphism. These are defenses designed to confuse and frustrate attackers. But reverse engineers are problem solvers at heart. They find patterns inside the chaos, detect fake control flows, bypass debugger detection, and step through encrypted code at runtime. What was meant to be unbreakable becomes slowly, methodically unraveled, not because they brute force it, but because they understand how it was built and where it made a mistake. Scene 7. Why this skill is respected and feared. Reverse engineering is one of the most respected skills in cybersecurity because it goes beyond tools. It's not about running scanners or launching exploits. It's about understanding systems at their deepest level without documentation, without help, and without shortcuts. A reverse engineer can expose a backdoor in a government-grade encryption tool or recover secret keys from a secured chip. They can dissect nation-state malware, trace its origin, and neutralize its payload. But in the wrong hands, the same skill can be used to defeat copy protection, weaponize stolen software, or repackage malware to evade detection. That's why this skill is not just admired, it's feared, because once someone learns to reverse engineer, very little stays hidden from them. To reverse engineer something is to unravel the truth buried beneath layers of abstraction, protection, and intent. It's the ability to see software not as a product, but as a sequence of ideas, instructions, and logic waiting to be revealed. You don't need the source code, you don't need the key, all you need is the obsession to look deeper. Because in this world, nothing is truly locked, only delayed. And for those who know how to reverse engineer, there are no secrets. Like, share, and subscribe for more. And remember, what's built by humans can be broken by humans. See you in the next one.